All right. So we were talking about average rate of change, right? For straight line or linear function, the average rate of change of the function, in fact, is the slope. It's rise over run, so it's the slope. And for other type of function, it will be different. So we want to talk about a little bit more about average rate of change. Last class, we covered 2 problems, and we plan to cover 4 of them, as I shown here. For the average rate of change, we plan to cover 4 examples. We finished number 7, number 3. Now let's look at number 2. Number 2, we are given a curve. By using the vertical line test, we can quickly determine this curve represents a function, right? Because there's no vertical line would pass the graph more than once. So we are looking at a function. We are looking at a function. We are looking at the graph of the function. We need to find the average rate of change. Actually, here is to estimate the average rate of change of the function from x equals 1 to x equals 2. Yeah, that's the problem. Let's see, how do we process this problem? Average rate of change.
Do just the
Here,
rise over the run.
yeah, rise over run, exactly. We don't have to worry about, this is not straight line, right? We don't have slope, but don't worry about that. If we plot the 2 points corresponding to the 2 x coordinates, we will have 2 points in the rectangular coordinate system. If we connect the 2 points, we will have a straight line. And the average rate of change of the curve of this function, in fact, is the slope of the straight line connecting the 2 points. So all we need to do here is, firstly, let's see where is x equals 1. On the graph, x equals 1 is here, right? On the x-axis. And the corresponding, this point is on the curve, on the function. And the y value of this point obviously is 0, right? This is the origin. So this point, this black point has 1, 0 as the coordinates. And the second point is x equals 2. Right here, this point on the graph has x coordinate 2. And the corresponding y coordinate is 5. I hope you see it. This is 2, and the y coordinate is 5, right? So the coordinates of this point is 2, 5. 2, 5. The average rate of change of this function, the curve, from x equals 1 to x equals 2, in fact, is the slope of this line passing through the 2 points, right? And we know it's just the rise over run. Let's see what's the rise and what's the run. When we talk about rise and run, it's better we determine a direction. And normally we go from the left to the right. It's like when you read a book, when you read some information on your phone or on your computer, you go from the left to the right, right? We follow the same order. Then from right to the left, sorry, from left to the right, this is A, this is B. From left to the right, so we determine we are going to from A to B. The rise is vertically. Yeah, what's the vertical change? Vertically from 0 to 5. And this point is on the x-axis, right? From A to B vertically, B is like a floor 5, 5th floor, right? So do you agree the vertical change is 5?
Yeah.
From A to B? Yeah, as you can see. Since the given information is a graph, we don't mind just to use the geometrical information or approach. And then run from A to B, follow the same order from A to B, from the left to the right. This is the horizontal change, horizontally. Horizontally, the change go from 1 to 2, go from 1 to 2. So the run is 1, right? So the run is 1. So rise over run. is 5 or 1? It is 5. So the rate of change, the average rate of change of this function that represented by the curve is 5. We should just enter 5 here, all right? Could we use the formula? Yes, we can use the formula as well. This is an easy way to handle it. Or we can also use the formula of average rate of change. We know the function. We are looking for the average rate of change of the function f, which corresponding to the curve over the interval 1 to 2, right? Because from x equals 1 to x equals 2. Then by the formula, the average rate of change is f of b minus f of a all over b minus a. Here, a is the left endpoint of the interval, which is 1. B is the right endpoint of the interval, which is 2, right? Then let's see what's the value for f of b and f of a. F of b would be the y value corresponding to the x value, which is 2, right? In other words, f of b is the output of the function when the input is 2. The entire course here, I will most of the time describe the function as a machine. The machine only produces exactly one output for any given input. I'll continue using this description. So here, as we can see, when the input is 2, when you give the function, the machine input 2, the corresponding output is 5, right? So f of b is 5. I want you to see it. I know by using rise over run, we can get the answer correct. But I also want you to understand the formula, and I want you to see the connection between the two approaches. And f of a represents the output of the function when the input is 1. So when you give the machine input 1, the corresponding output is 0. And then we plugging in the 4 numbers. In the numerator, f of b minus f of a, denominator b minus a. 5 minus 0, 2 minus 1, so we have 5. The same thing, right? Of course, I agree the easiest way is just to find the rise over run, right? To find the rise over run. Okay, any question about this problem? Average rate of change. Average rate of change. You might still remember the analogy or the example I gave you. Your teenager son has grown 3 feet in the past 5 years, right? I would recommend think about that example when you need to make sense of the meaning of the average rate of change of a function. In the example of your son, the two variables involved, the dependent variable is your son's height. The independent variable involved is the time. When time goes by, right, your son getting taller and taller. So the average rate of change is kind of like annual, yearly growth in your son's height. So I want you to make sense of the concept here. All right, so we have one more question about the average rate of change. Number 8. Find the average rate of change of function f of x. The function here is quadratic. If you know what I'm talking about, quadratic is fine. If you don't know, don't worry. In the future chapters, we're going to focus on that. So the function is 4x squared minus 8 on the interval 1, t. So this interval is different because this interval involves a variable, or you can see that as a ladder. Therefore, your answer will be an expression in t. Your answer will still have t in it. Okay, it's nothing fancy for this problem. You just need to use the formula. Let's see. The average rate of change is f of b minus f of a all over b minus a. A here is the left endpoint of the interval, which is 1. B here is the right endpoint of the interval, which is t. Okay, then what is f of a? f of a. So here b is t, a is 1. So in the numerator, we are looking for f of t minus f of 1. Okay, function f is given, the machine. How does the machine work is given. Now let's see, how do we find the output of the machine for given input t and 1? The function f of x equals 4x squared minus 8. So this machine, whenever you give the machine an input, the output always equal to the square of the input and then quadruple and then minus 8. Okay, so the pattern here, the output for this specific function is always equal to 4 times input square and minus number 8. Okay, so when the input is 1, I need a more space here. Let's see if I can get the idea. Just squeeze here. F of 1, the output of the function when the input is 1, right? Would it be equal to input square and then quadruple the square and then minus number 8. 1 square is 1. 4 times 1 is 4. 4 minus 8 is 94. So f of 1 is 94. What about f of t? We practiced how do we find the output for any given input, right? So even the input is not a specific number, even the input is a pencil or a a phone, right? So anything, as long as the thing is in the domain. Here, of course, the domain is all real number, has to be a number. But we have t here represents any real number in the domain. So when the input is t, the output for this specific function would be the input square and then quadruple the square and the minus 8. And that's it. It's just an expression in t. There's no way to get rid of t. T will stay here. Therefore, the numerator f of t would be 4t squared minus 8 and then minus f of 1. F of 1 is 94. We got it, right? Don't forget to put a parenthesis. I emphasize this a lot when I teach foundation 2, but since this is pre-cal, I assume you should be very good at handle operations of numbers with sign. So I'll go a little bit fast. So minus negative, don't forget, minus negative is better. You use a parenthesis to frame the negative number. Otherwise, it's very likely to mess it up. And we can clean the numerator, simplify the numerator a little bit more. 4t squared minus 8 minus 94. Minus 94 is plus 4, right? So this part is plus 4. So the numerator is 4t squared minus 8 plus 4 minus 4. I assume you also know the casino method to adding numbers with signs. Negative 8, positive 4. It's like you lose $8 the first game and then you won $4 later, and your overall profit is still negative because the first game you lose more than the second game you won, right? So negative 8 plus 4, 94. And the denominator t minus 1, gonna stay here, t minus 1. But this is not the final answer because you need to simplify it. You need to simplify it. Allow me to erase this part and we can continue. Numerator, the binomial numerator, 4t squared minus 4 has a GCF. You might remember the last chapter in Foundation 2. You should have learned factoring polynomials, right? Very important for pre-cal. Factorization of polynomials is very important for pre-cal. We're using it right now. We're gonna factor 4 out. Then in the parentheses, we have t squared minus 1. Let's copy the denominator t minus 1 and then use a parenthesis to frame it for a reason I'll explain. Denominator t minus 1. Numerator t squared minus 1 is t squared minus 1 squared. That is a difference of 2 squares. I hope you see it. It's a special binomial. It is a difference of 2 squares. We are able to factor that difference of two squares as t minus 1 times t plus 1. If you don't remember, I'm going to write a formula here. A squared minus b squared equals a minus b times a plus b. Maybe look at your foundation 2 note. This is a very important formula, okay? This is a difference of two squares. It's a special binomial. We can use the formula to factor it. We can factor it as t minus 1 times t plus 1. And as you can see, those two binomial can cancel each other, right? This one and this one, they cancel each other. So the result is 4 times t plus 1, and that's it. Questions? This problem doesn't really challenging you with the concept of average rate of change. It does challenge you, however, your algebraic ability, because it has a letter, it has a variable t in it. It requires you be able to operate the expressions very well, and also you need to remember how to factor polynomials, right, to simplify the result. Questions? Give me some feedback.
That it all makes sense pretty well with the
Okay, very good.
squares.
So no question, right? You are a little bit cut off.
No, thank you.
Perfect. Let me see. Do you guys know we have a chat function here? If you are welcome to just type the question there. If like unmute yourself is not convenient, you are welcome to type the question. And I actually prefer that way because I can see it better. Very good. So the second thing about section 1.2 is the intervals in which a function increases or decreases. So that's the last two questions in Lumen. The reason I have to cover the two questions is because last semester, exam 1, unit 1 exam, students have this type of questions in the test, but for that question, the successful rate was very low. I did not understand because it's supposed to be a very intuitive concept. Once you know, just know, right? I just confused a lot of students, messed up. Here, this semester, good news is that this is not completely online. This is online live. We are able to, work on some problems to make the concept more impressive. How do we find the intervals? The interval obviously have to be in the domain, okay? When we talk about the function increases, goes up, or rises, or decreases, goes down, declines, we are talking about the change or the trend of the function over an interval within the domain. Of course, has to be in the domain, okay? So the interval we are looking for must be the interval, must be part of the domain. So the interval is where the x-axis, where the x values locate. Let's look at the problem here. We are given a curve. Obviously, the curve represents a function because it passes the vertical line test, right? Goes down and it goes up and it goes down. And it seems like a polynomial function with degree 3. And in the future chapters, you would be able to tell what type of function this is. We are going to choose the correct one from the 4 answer choices. And this one is not challenging because multiple choice question. Pretend this is a free response question, and you need to identify the interval. Also, in the test, the problem will point out open interval. Yeah, this might be somewhere confuse students. What is open interval, guys? That means both left endpoint and the right endpoint are not included. In other words, the notation has to be parentheses, cannot be bracket, cannot be left bracket like a left close, right open, or left open, right close. Has to be both parentheses. So for one, you need to remember when you take exam 1, unit test exam 1, the problem actually stressed right at the open interval in which the function goes up or goes down, right? You have to enter parentheses. You can't use bracket. Okay, that's one thing I need to emphasize. So let's see which open interval or open intervals the function increases. Okay, let's see this part. The function goes down, and technically they should have this. Okay, without that, it seems like a stop, but actually they should have a arrowhead to indicate this continue forever, this one continue forever as well. And as you can see, for increase, this part is increase, right? And so we are looking at the corresponding x value, okay? So from here to here on the x-axis, the domain is on the x-axis. So the open interval in which the function increases is from -3 to 0. Do you agree, guys? From -3 to 0. So here, right? From here to here. And this point has x-axis -3. And this point has x value 0. Don't forget to put the parentheses to indicate that's an open interval. When we talk about function increasing or decreasing, we use open intervals only. Is that clear, guys? I think once we practice a couple, you would not get confused by this type of problem. Are we good? Why is it increasing? Again, because you are looking at the graph from the left to the right. That's the correct order. I mentioned earlier, right? Just like when you read a book. When you read a book, you don't go from right to the left. That's weird, right? Maybe some of culture do that, but modern time in this country, we go from left to the right, right? When you look at the graph from the left to the right, the green part I highlighted, that part increases. Okay, increases. But you do not do 94 and 0. You don't do that because we are looking for part of the domain. So it has to be x, has to be x. Maybe this would help. This part is increasing, right? They start from this point, ends at this point. Just focus on those 2 points. And starting point has the x-axis 93, so you put a 93 here. The ending point has x value 0, so you put a 0 here, and then parentheses. Maybe that would help. Again, you go from left to the right. You are looking at the curve from left to the right, not the other way around. Then let's see what are the intervals in which the function decreases. Okay, this is increases. I just use that symbol. For decreasing, let's use a different color. This part is decreasing, and now this part is also decreasing. So 2 parts, right? 2 parts. So we're gonna write both. The first part, I want to use a different color though. Purple. The first part is the purple part, right? And then use the strategy or the technique I showed you earlier. You draw a pointer here and you draw a pointer here, right? Starting point, again, from left to right. Starting point has x value, I have to erase that in order to see the point better. Oh, actually, this arrowhead is important. It doesn't have a point here. It doesn't have a point. It has arrowhead. That means that purple piece goes from negative infinity, guys, not 95. Okay, was very easy to make mistake. It's from negative infinity, and then the ending point. This circle has -3. So this interval is an interval the function decreases. Let's look at the pink. We have another interval in which the function is decreasing. This decreasing, this increasing. The pink one, also you can use a strategy, draw the point, but when you see an arrowhead, you don't really have a point because continue all the way to past infinity, right? So you have a past infinity as the right hand point. Left hand point is 0. On those two, in those two intervals, the function decreases. Is that doable, guys? If you understand that, let's look at the answer choices, and you tell me which one is correct, which one is consistent with our result earlier. I don't know if you can see it. This bar, I want to.
The third one.
I put the answer we got into the assignment, but it didn't work. Which question? It said the answer was supposed to be
The one that we just did before this. I put it in there and it wasn't
1 + 8
working.
instead of. Okay, let's look at the problem. Lumen, let's go to the Lumen. Let me stop share my note. Let's share the browser. So now we are here. Which question that is? The question 2 or question number 3? Number 3? No.
It was number 8.
Number 8, okay. Let me double check my solution here. 4x squared minus 8. Average rate of change. So 4t squared minus 8. When you plug in 1, is 94, so plus 4, so minus 4. 4t plus, my answer is not wrong. Is your number might not be the same with mine.
It was the right one. Now it's switched,
That one?
but the one that we were doing, I did get the same question and it said that it was still wrong.
Oh, so let me enter, what's our answer? I got a 4 times parenthesis t plus 1, right?
Yeah.
Let's try that. 4 times parentheses t plus 1. Let me double check the question is the same question. 1 to t. It shows correct. You see that? The green check mark means it's correct.
Yeah, I don't know what's wrong with mine then because it said it was wrong and I put the same thing for the same question.
You want to put a 4t plus 4, that might work as well. 4t plus 4 means you remove the parentheses, but you won't have an 8. You will not have 8. And this works as well. Without the parentheses, with parentheses doesn't really make too much difference. Can you make a screenshot and email me what do you see on your end?
The question changed already. I can't
Already?
see that
Okay.
question anymore.
Oh,
So I'm gonna have to try it again later, but
yeah. Our answer was correct, by the way. Okay, let me stop share. Let's go back our notes. My note right here. No. That's why I missed the Ultra. I don't have to do this. I can just share the whole screen. All right. So this is the increasing, decreasing problem. Guys, look at the 4 answer choices. Which one is the correct answer? I have enough of the information for you to determine because the graph is right here.
It's the third one.
Third one, awesome. C, perfect. You're right. Okay, the function is increasing on. It says on, but sometimes we say in for open interval, on for closed interval. But it really doesn't matter. We don't have to pick on that to do problems. So on 9320, the green one, the green part decreases on the purple part and the pink part. Very good. Do you guys remember I said I stressed it has to be in open interval, okay? Please don't forget that when you take exam 1. One more. This is also a function, right? Go up, go down, go up. And we are going to find the interval on which the function increase. Yeah. This time you don't have anything to choose from. You would have to do it yourself, right? Let's see. It says increasing first. So the purple part increasing. Is that pink? It's pink. This color increasing. Don't forget, this is an arrowhead. This is arrowhead. And that's not very strict. That's supposed to have an arrowhead. So we have two intervals on which the function increases. The purple one, you see, again, you look at the graph from the left to the right, right? Look at the purple part from left to the right. So it starts from the arrowhead, from the net infinity. And then stop at right here. That is 92, right? Look at the x value of the point. Again, the intervals we are looking for are part of the domain. Part of the domain. Domain is on the x-axis. So that's the purple part. We also have another interval on which the function increases, the pink one. And you can draw a point starting here and end to infinity. So you know the radial point is infinity, positive. And this point has x value positive 1. Over those two intervals, on those two intervals, function increases. For decrease, the green part is the decreasing part. And it starts from this point, ends at this point, right? Again, look at the x values. Start from 92, right? Ends at positive 1. Over this interval, function decreases. Over the other two intervals, function increases. I will leave this for you to practice. The problems you see in your exams, we have 4 mandatory unit exams, right? Unit 1, 2, 3, 4. And those problems are not new or any fancy or designed to challenging you. They are just the same type of problems from the same question bank. And the homework assignments problems, they are very similar, okay? Yeah, the 4 exam questions, they are just from your homework questions. Maybe the number varies, but the type of the question is the same. No surprise, no challenge. And the midterm and the final, those 2 exams, the problems are from the 4 exams, the 4 unit exams. Maybe the number changes. Like earlier, if you try again, the number would change, right? And that's something programmed in the system. I cannot control that. But the type of a question is the same thing. Seriously, if you take the homework assignments problems seriously, you should expect to have very good score from this class. All right, we finally finished section 1.2. And what do we do in section 1.3? We do linear function. And linear function is just about straight line. And you have learned straight lines from Foundation 2. Foundation 2, Chapter 3, the whole chapter is about straight line. I will remember to post my past videos in Foundation 2 regarding straight line. Let's see if I can post them in Blackboard. And in this class pre-cal, we're gonna just you will see I go over this. I cannot go very slow. I might go over this type of content faster than, because it's not new. All right, let's start from number 12. 3 forms of linear equations in 2 variables. Linear equations in 2 variables correspond to straight lines in a graph. We have 3 forms for the equations representing straight lines. The first form is called a standard form. It is ax plus by equals c. X and y are the 2 variables. Since we are studying straight lines in the rectangular coordinate system, which is a 2-dimensional space, so you have 2 variables, x, y. A, B, C are numbers, real numbers here. A, B are not, both zeros. There's a lot of details, both zeros. Anything that can be written in this form is a linear equation in 2 variables that represent a straight line in a rectangular coordinate system, right? A here is the coefficient of x. B here is the coefficient of y. C here is the constant term on the right-hand side. Second term, very important, slope-intercept form. Slope-intercept form is the most popular form for straight line. You must know this one. And the slope-intercept form, another reason it is important is because it directly gives you the linear function, y equals mx plus b. When we present a function, we write the dependent variable by the self on the left side. So the slope-intercept form of a straight line directly gives us the function, the linear function corresponding to the straight line. So as you can see, the 2 variables, x is on the right side, variable y on the left side by the self. On the right side, m here is the slope. M is the slope or rate of change, right? Average rate of change we just learned. 0, b is the y-intercept. I hope you remember what is y-intercept. Y-intercept of a straight line or any other graph is the intersection of the graph with y-axis. So that point has x value 0. When you make x be 0 here, y value would be b. That's the reason 0, b represents the y-intercept of the straight line. Since we're able to identify the slope and the y-intercept directly from the form, the name of the form is slope-intercept form, okay? The third form is called the point-slope form. Point-slope form. It is y minus y1 equals m times x minus x1. Maybe some of you like this type of form, is okay. You can just use it. Here, x1, y1 is a point on the straight line, and m is the slope. But here, I'm going to skip this form. Try to focus on slope-intercept form, the most important form. Why do we need a standard form? Because the standard form is the only form that may define a straight line. Slope-intercept form and the point-slope form, they have a limitation. What limitation? They only apply when the straight lines are not vertical. Vertical lines do not have slopes, if you remember. Vertical straight lines do not have slopes. In another way to say it is vertical straight lines, slope is undefined. So that's why slope-intercept form, point-slope form, since they have slope in it, they can only apply to non-vertical straight lines. So this is the reason we need a standard form here. Okay. Again, I'm going to focus on slope-intercept form, but when we need a standard form, we'll talk about standard form, right? Number 13, I give you a straight line. That is in the standard form. If you can tell, left side of the equation, 5 times variable x plus -2 times variable y, right? On the right side, you have a number. So your a is 5, your b is -2, coefficient of x is 5, coefficient of y is -2, and the constant c is on the right side. We need to look for the following 4 things. The first thing, x-intercept. Again, what is the definition of x-intercept? Sept here. I believe you know in English, it means cut. So x-intercept, let's say we have the rectangular coordinate system. This is the x-axis, this is the y-axis. If you have a straight line, let's say the red one, and the straight line cut the x-axis here, and that point is called the x-intercept. Okay? It is the intersection of the straight line and the horizontal scale. Similarly, you should be able to understand what is the y-intercept, right? Y-intercept is the intersection of the straight line with the y-axis. As you can see, the orange, kind of like red as well. Red point is the intersection of the line with the y-axis. Okay, let me show you the process of finding x-intercept and y-intercept. It is very convenient. Not absolutely. Most of the time, it's very convenient to find the x-intercept and the y-intercept when the straight line is given in the standard form. Let me show you, okay? To find x-intercept, make y be 0, okay? So our equation is 5x minus 2y equals 10. Let me show you how convenient it is when the equation is in the standard form and we need to find the x-intercept and the y-intercept. To find the x-intercept, make y be 0. Does that mean this part gonna disappear? You agree? This part gonna disappear, right? Because you make y be 0, and that part gonna disappear, right? And this part is going to disappear because y equals 0, right? And then what do you have now? You have 5x equals 10. I believe most of you are able to quickly calculate or solve the equation. If 5x equals 10, what is x? Huh?
2.
Yeah, there you go. So we got it. X-intercept is 2, 0. Done. See how convenient it is? Yeah, most of the time, not absolute every single case, but most of the time is very convenient. All right. To find the x-intercept, make y be 0. So this part disappear. And you can quickly solve this equation for the value of x. X equals 2. So 2, 0. 2, 0 is x-intercept. In our book, sometimes they say x-intercept is 2. Technically, it's incorrect because both x-intercept and the y-intercept, they are points in a rectangular coordinate system. They are ordered number pairs. They're supposed to have 2 components. The correct way to say x-intercept is 2, 0. You have to give me a point. You have to give me 2 components in a pair. But even when you work on Lumen, some questions is not very strict. Maybe some problem only require you to write 2. What's the x-intercept 2? And they count it as right. Then you just go with it. We have to adapt, right? If the system just asks you to write one number, that means the x coordinate for x-intercept and the y coordinate for the y-intercept. They assume you know x-intercept have a y value 0 and the y-intercept has x value 0. I hope you understand what I'm talking about here. Yeah, again, this is not new, so I'm not going to go very slow. I will post my videos from the past, then you can watch later. For y-intercept, to find a y-intercept, make x be 0, because y-intercept is on the y-axis. Any points on the y-axis have x value 0, right? And let me show you how convenient it is here. 5x minus 2y equals 10. This time we are looking for y-intercept. So make x be 0. Make x here be 0. If we make x be 0, then this part disappear, right? No more. Can you tell me what is the y? What's the corresponding y value? Positive or negative? Be careful with the sign.
5.
Positive or negative?
Positive.
Or
or negative, sorry.
Yeah,
Negative.
sorry, maybe my mouse is covering. Negative 2y equals 10. Y is negative 5, right? So is it 0, negative 5. 0, negative 5 is the y-intercept, right? Negative 2 times negative 5, positive 10. Very convenient. For 1.3 homework assignments, it has a lot of details from Foundation 2. I try to cover as many as possible in the class. X-intercept and the y-intercept are important. You definitely need to know. When the straight line is given in a standard form, and if the problem requires you to graph the straight line, you know, by common sense we know two different points determine a straight line, right? If you can quickly find the x-intercept and the y-intercept, then those are 2 points. And you connect them, you have the straight line. So this is the x-intercept and the y-intercept for a straight line. The same idea applies if the graph is not a straight line. Any other functions, their graphs are curves, right? And they also have x-intercepts, sept or septs, or y-intercept. And same idea. You want to take notes. Here's very important. To find x-intercept, make y equals 0, and then solve for x, right? And then the pair with x and y, and that's the x-intercept. To find the y-intercept, make x be 0, and solve for y. Solve for y. Those are Q's, C-U-E, for solving this type of problem. I don't know if you ever, probably many of you go to gyms, right? There's some classes you do yoga or cycling, and you have to listen to what the coaches say. Those are cue. Like the coach say, lift your left arm, lift your right leg, and you know what to do. So when we need to handle a math problem, we need to know what to do, right? So it's a good idea to memorize some cues. For example, this that I just gave you for finding x-intercept and y-intercept, those are good cue. Remember them. To find x-intercept, make y be 0, and then solve for x. To find the y-intercept, make x equal 0, and then solve for y. Of course, understanding first. Understand it first, then you can easily to remember the cue. Next, we need to graph the line. As I mentioned, if we have 2 points on the line, we can easily graph it, right? x0, x-intercept 2, 0, right here. Y-intercept 0, -95, 1, 2, 3, 4, 5, right here. Okay, we got the 2 points, we connect them. There we go. That's the straight line, right? So if the line is given in the standard form, use the x-intercept and the y-intercept to graph the straight line. The last one, slope. Okay, you can try to find a rise over run, but I'm going to give you a formula. Sometimes it works very well. ax plus by equals c. That's the standard form of a straight line, right? The slope is negative a over b. Maybe some of you like it. If not, it's totally fine. Just use the graph to find the rise over run. But if this method is for you, pay attention. So here, A is the coefficient of x, B is the coefficient of y. And you take the quotient of the two numbers and then flip the sign. Okay? What happened is, look at the left side. So the slope only related to the left side in a standard form. So once you grasp this method, like I know this method, it only takes me 1 second to find the slope. I don't have to look at the graph, the count, rise and run. Yeah, that's the reason I want you try to grasp this method. And when I look at the left side of the equation, 5x minus 2y, since this term, the first term and the second term, they have different sign. When they have different signs, slope is going to be positive. Okay? If they have if they have the same sign, slope is going to be negative. But since here they have the opposite sign, slope is going to be positive. Positive what? 5/2. Do not worry about the negative sign in front of 2, because you already know the sign is positive. 5/2, done. Yeah, give it a try. If not, just try rise over run, right? As you can see here, rise 5, rise 2, 5/2. That works as well. But if you know this method, 5x first term, negative 2y second term, they have a different sign. So the slope is positive. Positive what? 5/2. Done. The number in front of x over the number in front of y. You're good. All right. Number 14. Number 14, I'm giving you a equation representing a straight line in a slope-intercept form. Okay. Slope-intercept form. Let's see if I can insert a page break. This is 13, this is 14, okay. So this straight line is given in the slope-intercept form. Formula y equals mx plus b. That's the formula. M here is the coefficient of x, represents the slope. B here is the y value of the y-intercept. So it's -3, right? Slope would be 3/4. Slope is 3/4. Y-intercept 0, -3. In the system, you might only need to enter 93. So read the question carefully, especially the fine print. It has a lot of information in it. Pay attention. No, just figure out what the system wants you to do, right? Just enter a order the pair, and order the pair was just a value. Graph the line. I'm going to show you how do we graph a straight line by using the slope and the y-intercept. Firstly, we locate the y-intercept. The y-intercept here is 0, -3. So this is the orange, right? Go down 1, 2, 3. This point is the y-intercept. To use the slope and the slope-intercept to graph the line. Plot the y-intercept first. And then what do we do? Use the slope here. Write the slope as a fraction. We are lucky it's already a fraction, right? 3/4 is a slope. And then write it as a rise over run. To determine what's the rise and what's the run. And in this case, rise is 3, rise is 4, right? Okay. So from the y-intercept, rise 3, 1, 2, 3, and run 4, 1, 2, 3, 4, to locate a different point. You can continue doing the same thing more times. 2 points are enough, but if you want more points, you can do the same thing. What same thing? You rise 3, 1, 2, 3, and then run 4, 1, 2, 3, 4, right? And you would have another point. As many as you want. And you will see those points are all collinear. They should be on the same straight line for sure. And now you have your straight line. I have a question. What if the slope, okay, it's not this problem. What if the slope is negative 1/2? How do you find your rise over run? You can write negative 1/2 as negative 1/2 or 1/92. The negative sign in front of the fraction can go with the numerator or go with the denominator. To make the simple for you, just do 1. For example, you do negative 1/2, right? Then your rise is going to be negative 1. Your rise is going to be 2. So you're going to go down. Rise is a negative, so you go down 1 unit. Rise is a positive 2, so go to the right 2 units. Does that make sense? If you have a negative sign, how do you handle the negative sign? Put it either with the numerator or with the denominator. What if your slope is 5? It's not a fraction, it's an integer. Then you can write 5 as 5/1, right? And your rise is 5, your rise is 1. That works as well. What if your slope is -2? And that is -2/1. So your rise is -2, your rise is +1. Go down 2 units, go to the right 1 unit. Any questions? I might be fast to some of you if you don't remember much about straight lines from before. Questions?
No, I understand it. You explained it really well.
Perfect. Thank you. Thank you so much. All right. Number 15. Number 13, I give you a straight line which is a slant or oblique straight line in a standard form. Number 14, I give you a slant straight line in the slope-intercept form. And number 15, we have a 2 straight line. Looks kind of weird, you know. Let's see what's going on here. Number 15, the first equation is x equals 4. X equals 4. X equals 4 in rectangular coordinate system also represents a straight line. If you have an equation, of course, the question would point it out. It is is in a 2-dimensional space. So this is the x equals 4. This equation only has variable x. It does not have variable y. This type of equation is a vertical straight line. All right. If you have an equation represents a straight line, but the equation is missing variable y, that means the straight line is vertical. And how do we graph the vertical line? Here, x equals 4. How do we graph it? In a rectangular coordinate system. This is the x, right? This is 0. So this x equals 0, x equals 1, x equals 2, x equals 3. Here we go. X equals 4. At x equals 4, draw a vertical line. Similarly, when the equation only has a variable y without a variable x, like y equals 92, and it represents a horizontal straight line. All right, horizontal straight line. I'm gonna graph the line here. A lot of students confuse one with the other. Which one is vertical? Which one is horizontal? Horizontal y equals 92. Y, so on the y-axis, right? Look for 92 on the y-axis. This is 0, right? This is 1, 2, and 91, 92 would be below the 0. So 91, 92. So this is y equals 92, right? Y equals 92. You can't draw a vertical line here. You have to draw a horizontal line. Otherwise, you would draw the only vertical line you can draw is the y-axis. So maybe that helps you to figure out which one is horizontal, which one is vertical. If the equation only has x, vertical, if the equation only has y, horizontal, two special type of equations corresponding to special type of straight lines. So we have vertical, we have slant, we have vertical. You know, actually, this question number 14 should have a negative. Would be better if this equation is negative. Okay. About the slopes of the straight line. If the line goes up, slope is positive. If the line goes down, slope is negative. If the line horizontal, slope is 0. If the line is vertical, slope is undefined. I hope you remember this from Foundation 2. And number 16, we are going to do an exercise. In this table, we have two concepts involved. The two concepts are opposite and reciprocal. After we review or recall the concepts opposite and reciprocal, we are going to introduce a new concept. Okay, let's do the opposite first. Opposite here means the sign is opposite, okay? The sign is opposite. Two numbers are opposites if they have the same absolute value but different sign. The first number we are given is 3/4. 3/4, right? It is positive, even you don't see the positive sign. Means it is 3/4 or 3/4, 0.75 unit to the right of the orange on the real number line. Its opposite simply is just a negative 3/4. Okay? When we look for opposite, we only change the sign. When we look for the opposite, we only flip the sign. The opposite of positive number is negative. The opposite of negative number is positive. So the second number is -2. The opposite is +2. Of course, you don't have to write a positive sign here, right? You can just be 2. The third number it is given is 5. The opposite is -5. The first number we are given is -2/3. The opposite is +2/3. Okay, do you remember how do we find the opposite? And what is opposite? Opposite do not change the absolute value. It only change the sign in front of the number, okay? Reciprocal is different. Reciprocal does not change the sign. Reciprocal only flip the numerator and the denominator. The first number 3/4. The reciprocal of that number, it is still positive. Again, reciprocal does not change the sign. If it's positive, the reciprocal is still positive. If the number is negative, the reciprocal of the number is still negative. So number 1, the number is a positive 3/4. The reciprocal is still positive, but it is 4/3. We flip or swap the top and the bottom. 4/3. Interchange the numerator and denominator. That is reciprocal. Number 2, -2. So the reciprocal is still negative. 2 can be seen as 2/1. So the reciprocal is 1/2. Right? Number 3 is 5. Reciprocal is 1/5 because 5 is 5/1. So the reciprocal is 1/5. Number 4, the number, okay, we are looking at the first column, okay? We are done with the second column. So the number 4, the last number that is given is -2/3. Its reciprocal is still negative, but 3/2. Okay? If we understand what is the opposite, what is reciprocal, we need a concept that combines those two. It is called the opposite reciprocal. The opposite reciprocal of 3/4 is -4/3. As the name shows, you do both. The number is 3/4, positive. And you do the sign, you flip the sign, also swap the top and the bottom. You do both. You combine the two processes. And the second number is 92. So the opposite reciprocal is going to be positive 1/2. The third number is 5, positive. So negative 1/5. Last number is negative 2/3. The opposite reciprocal is going to be positive 3/2. Okay, that's the definition for opposite reciprocal. I didn't really give you a definition, but I show you what does that mean. The process of finding the opposite reciprocal. I want you to help me to multiply the given number and its opposite reciprocal together. Can you tell me the product of those? The number is 3/4. Its opposite reciprocal is -4/3. Can you multiply the two numbers together and then tell me what's the product? 3/4 times -4/3. What's their multiplication? Huh? 3/4 times -4/3. You can use a calculator.
-1.
Thank you. Exactly. -1. Perfect. All right. This is not coincident. You can keep trying. -2 times +1/2 is also -1. 5 times -1/5 is -1. -2/3 times +3/2 is -1. The number multiplied with its opposite reciprocal gives -1. Why are we learning opposite reciprocal? Because we need it when we study two straight lines, and the two straight lines are perpendicular. You might remember parallel and perpendicular, right? Okay, let me give you the theorem. We have two straight lines, L1 and L2. I'm using the notations here. L1, L2 are two different straight lines, okay? If L1 parallel with L2, that's the notation for parallel. The two lines are parallel. If they are parallel, then they have the same slopes. Yeah, here, M1 is the slope of L1. M2 is the slope of L2. Vice versa, if two straight lines have the same slopes, then they must be parallel. So this notation means if and only if, two directions. Let me explain again. If two different straight lines are parallel, they must have the same slopes. Their slopes must be identical. Vice versa, if two different straight lines have the same slope, then they must be parallel. We understand what is parallel, right? Two straight lines never touch. They, when you're driving on a highway, suppose the highway is straight, not curved. The two lanes, the two white or yellow line frame the lane, they must be parallel. And if we have two different lines and they are perpendicular, we also should know what is perpendicular. Perpendicular means two straight lines cross, and the angle formed by the two straight lines are 90 degrees, so that is a perpendicular. They have to cross. They also have required the angle has to be 90 degrees. If the angle like this one is not 90 degrees, they are not perpendicular. Okay, they are not perpendicular. If two straight lines are perpendicular, then let me erase this. Their slopes are opposite reciprocal of each other. In other words, M1, M2 multiplied to -1. Okay, vice versa. This is the condition for two straight lines to be perpendicular. Graphically, you're gonna see they have 90 degrees, right? But sometimes the graphing is not will not always work. For example, 91 degree or 89 degree is slightly off, then they are not perpendicular. But it's really hard to tell we have to use algebraic method to determine if they are perpendicular, right? Then the way to determine if two straight lines are perpendicular or not is to use their slopes. If their slopes multiply to -1, they are perpendicular. In another way to remember the condition is use the opposite reciprocal. If two straight lines, their slopes are opposite reciprocal of each other, the two straight lines are perpendicular. Vice versa, if the two straight lines are perpendicular, then their slopes must be opposite reciprocal of each other. That's the reason earlier I gave you a warm-up to talk about opposite reciprocal. I consider this part as a challenging part, so I put it here. Hope it helps. Now let's look at number 18. Number 18, get more space here. We have 4 minutes. I think I can get it done here. Number 18, give the equation of the line passing through the given point 9, -14 that is perpendicular to this given straight line. Firstly, I want to graph what's going on, okay? I'm going to use what color? A black color, okay? This is the black color. So in a rectangular coordinate system, since the slope is positive, this is the straight line y equals 3/4x plus 8, okay? And we also have a point. Let's say the point is right here, 9, -14. The point is not on the black straight line. So we are looking for a red line that passes the given point and perpendicular to the black straight line. The black straight line is y equals 3/4x plus 8. We are not looking for that. It's already given. The black straight line corresponds to the given equation y equals 3/4x plus 8. And we also have a point 9, -14. We are looking for the red one. We're looking for the equation of the red straight line passing through the given point and perpendicular with the black straight line, perpendicular to the black straight line. That's our goal here. That's how do we understand the problem graphically. Now here we are going to handle the problem algebraically because the equation is a concept in algebra. Okay, I'm gonna do this, okay? First, I need to ask you the question. What is the slope? The slope of the red line is, I'm sorry, can you say that again?
I'm sorry, I was talking about the first line.
The first straight line, the black one, slope is 3/4. You're right. The black one, okay, the slope of the black line is 3/4. You are right. That's awesome. And what about the slope of the red straight line? And they are perpendicular. Remember opposite reciprocal?
-4/3. Oh.
Exactly. There we go. Exactly. Very good. Perfect. So the equation of the red line can be written as y equals -4/3x plus b. I use the slope-intercept form. One reason is because the question asks you to write the result in a slope-intercept form. Look here, Lumen. All the questions requires slope-intercept form. So use this method. Then I write the red straight line as y equals mx plus b. And we know the m already, right? Is -4/3. So m is -4/3. Plug in here. And b is the only number we need to figure out. How do we find the b? To find the value of b, plug in
0,
x equals 9, y equals -14. The given point, right? The given point is on the red straight line. So the ordered pair 9, negative 14 should satisfy the equation here, the red one here. Okay, let's plug in. Y is negative 14. X is 9. 9 can be written as 9 over 1 plus b. You can use your calculator to handle the fraction. And negative 14 equals, so 9 over 3 is 3, right? So this becomes 1, 9 becomes 3, so negative 12 plus b. Okay, guys, what is b? Negative 14 equals negative 12 plus b. What's the value of b? Which value satisfies negative?
-2.
Awesome, very good. You guys are great. Okay, here we're done. The answer is going to be the red line is going to be the red one is going to be y equals negative 4 over 3x minus 2. Finished, right? It's 10:50. I went a little bit fast. My excuse is this is from Foundation 2, not a new thing. I will remember to post videos from the past. Let me share the Blackboard very quickly. Lumen. Here, the browser. In our Blackboard, I'm gonna apologize. I posted the section, but I forgot to make it visible to students. So I just noticed this morning. I apologize for that. So this is the new section I added. I will lead us to our class recording. I remove some personal information from the beginning and the end, and you can look at that. I also have my Foundation 2 videos posted in my YouTube channel. I will give you the link, then you can maybe if you want, you can study the straight line part. All right, guys, we ran out of time. Thank you so much for coming. Keep working on your Lumen assignments. Do not take any questions lightly. Try to repeat the same problem more times. It has an option. You click similar questions, they will give a similar question you can practice. I'm just afraid if you only do it once, you won't be doing too well in the exam. So for the purpose of the exam, you should do more times for the same type of problem. All right, guys, thank you so much for coming. I'll see you on Thursday. Email me if you have any questions.
Thank you.
Bye.
Bye.
Thank you.
Bye-bye.
Bye.
Bye-bye.
Thank you.
You're welcome. Bye-bye.